Okay, the stream is going. Cool. All right. I will hang on. Okay. Promoting Joan to panelist. Joan, can you turn on your video and audio?
Yeah, hello.
Perfect. Good stuff. Actually, I'll promote you to a host. So that just means we won't have any issues about screen share. Awesome. Cool. Deggy's here. Good to see you, Deggy. And Giancarlo. Good to see you both. Okay, we'll just wait for things to fill up a bit. We've had like 30 people register on Meetup, so we're expecting quite a few more to join. Remember, if you do want to chat over Zoom, say hello to everyone. There's a little box above the chat in the chat window that says "to," and by default, it's only hosts and panelists. So if you want to chat to anyone else, be sure to click that and select everyone. Okay, Kung Kiat, hope I'm saying your name right. Good to see you here. I think you're a new face. Kung, do you want to leave a little bit of info? Where are you from? What do you do? What's your background? What's your social security number? Name of firstborn pet? And I think in future, we should probably have some background music. So if anyone's really good at humming, do let us know. Cool. Remember, if you're introducing yourself, be sure to click, there's a little thing that says hosts and panelists. Click that and then click everyone in the chat window. Otherwise, only us hosts and panelists can see you. Man, Jina is growing so quickly. I have to look at this list and really think sometimes who's working for Jina and who is a community member. If anyone actually wants to introduce themselves by talking, raise your hand. I'll open the mic to you. Okay, it's filling up slowly. Obviously, people are still relaxing after a good new year. Oh, hey, Priyansi, good to see you here. Okay, we've got a few people joined up now, so I guess we can officially kick off. All right, welcome to another Jina AI Engineering All Hands. It's our monthly event where we share what we're doing, introduce the latest features of all the Jina ecosystem. So that Jina ecosystem being Jina Core, Jina Fine Tuner for improving your model's performance, Jina Hub, which makes it easier to integrate all the different encoders, segmenters, yada, yada, yada that you want, and our upcoming DocArray project, which we will introduce with EAH. Yeah, if you have any questions during the event, please leave them in the Q&A section at the bottom. If you want to chat, there's also the chat section at the bottom. Be sure to click everyone if you want to send a message publicly. Otherwise, only us hosts and panelists can see it. And if you're new here, or hell, if you're a returning community member, or even someone who works at Jina, feel free to leave a chat message introducing yourself, say hi. For future EAH events, we are always looking for new speakers as well. So if you have a topic related to Jina that you want to speak about, or if you've used Jina or built something, or if you can just hum really well and want to provide background music for the lull when things are starting out, do let us know in the chat below or in Slack at slack.jina.ai. So today we've got three speakers, my gorgeous self being one of them. So I will be speaking about the multimodal fashion search that I built. Our CTO, Nan, will be speaking about our new RocketQA encoder. And Joan Martínez, our principal engineer, will be introducing the new Jina DocArray. Cool. Okay, we've got some stuff going on in the chat already. Hey, Priyansi. Cool. All right, at the end of the session, we'll open the floor to anyone who wants to speak. So yeah, strap in, stay tuned, and I'll get started with introducing the cool thing I built. All right then. Can everyone see the screen? So used to saying that. I'll take that as a yes. All right, so on examples.jina.ai, we have a whole bunch of examples that we built using Jina. We've got the mobile game search. That's quite a basic App Store style catalog that you can search through. Meme search, you can use state-of-the-art models to search through different memes. And the new one, the fashion e-commerce search, the one I just built and the one I'm demoing to you today. All of our talks will be pretty short today, clocking in at 7 minutes or less if we're good at looking at the clock. So none of this is going to drag on too long. So if we go here, let's open that baby up. So as you can see, if you're familiar with Streamlit, I've built the front end in Streamlit because my CSS and HTML and JavaScript sucks. So we've got a basic text query box. We use text to search through images. So if I type men's blue shoes, whoops, we'll see what comes up. A whole bunch of different shoes for men, most of them blue. Surprise, surprise. Children's party clothes that are colorful. And we've got colorful children's party clothes. So the way this works is if we look at the code just here. So the documents we are grabbing from a data set that I got from Kaggle, a really nice product data set. And we have two different flows. We have the indexing flow, which the important thing here is clip image encoder. It looks at all the different images and stores the embeddings for those. And then when we're querying, we are using the clip text encoder. So again, this takes the query you just typed in and creates embeddings for it and compares the embeddings to what's in our index. Because these are both clip models, they both encode the same embedding space. So with this, you can search, well, on Jina Hub, we've got clip image encoder, clip text encoder, which I'm using both of, and also a clip audio encoder. This means you can search images with text, text with images, audio with text, any combination of the above, just by creating different flows for indexing and querying. Another cool thing we've got here is PQ Lite Indexer. A lot of you may have used Simple Indexer in the past. I really like using PQ Lite Indexer because something we can do now is filter on the metadata. So we can search for black shoes for, let's go back to this. So children's party clothes that are colorful between 2015 and 2019. Okay, we've got, that was working earlier. Maybe there's a bug in my code. I wouldn't be too surprised. Let's try to filter by price then. Maybe that's hooked up properly. Oh, demo effect, how I love you. Anyway, I will fix that by tomorrow, I hope. And in the meantime, if you want to play with this, examples.jina.ai/fashion. The stuff I'm using, because I'm lazy and because it's way more efficient and cooler, I just use all the executors from Hub. So we've got doccache. This checks for duplicates in the index. So if I re-index data, I'm not re-indexing the old data, just the new stuff. It essentially deduplicates the encoders for text and image, PQ Lite Indexer, so we can filter on different columns. And all in all, it's not many lines of code, about 100 lines of code, if that. We've got a few helper functions, of course, but yeah, nothing too major. So you can build your own multimodal search for whatever you like in under 200 lines of code total. It's all open source, of course. The repo is right here under my personal GitHub profile. We'll share the links in the Slack and the Zoom chat as well. So one of my team, Shreya or Joe, if you can share the link to the repo, the link to the examples.jina.ai, go for it. And yeah, if anyone has questions, leave them below. Thanks, everyone. All right, now, so who would like to go up next? Nan or Joan? Any preferences, guys?
I don't care. I can go next. I see maybe Nan.
Okay, Joan, you go for it.
So let me share my screen. So today I want to present like the new member of our Jina ecosystem family, that is the DocArray. So for some of you that are not new to Jina, these concepts might seem familiar, but this is like the next step in the evolution of DocArray. And for those who are new, so what is DocArray? So DocArray is what we want to we like to call is a data structure for unstructured data. So this is the a data structure that Python users, it is aimed for Python users, and we aim for this to be loved a lot by data scientists and deep learning engineers. It is a very friendly and Pythonic way of dealing with any media type. It can be text, data, text, images, audio, 3D meshes, whatever, even columnar data types. And it is a very easy to use way to encode these documents, match these documents using nearest neighbors algorithms, to visualize data, to break data to a purposes, and to apply data. Okay. There are two main concepts in this document array. So there is the document, that is the main unit on which you can reason about your documents, on your data. So it is a data structure that it is easy to represent, and it's nested and structured. So by nature, a lot of the data that you use to do neural search with, it's unstructured. It doesn't have a static schema. So text, images can come in any shape and whatever. So there's a lot of challenges that come with these types, and document array aim to help you with this. And then document array, that is the object that gives name to the package, is just a container that contains several of these documents as a list. It makes it feel like a list, but under the hood, it does a lot of tricks to make efficient use and access to elements there. So I think it's important to see a lot of alternatives. I wouldn't call it alternatives, are packages or from which we took some inspiration, and that some of them we took some things from them and some of them we didn't apply. So things we have been inspired by NumPy, by JSON, by DataFrame. We have been very influenced by Protobuf, and you can see a lot of these things. Some of these packages or tools excel at some of the applications, but DocArray has a lot of support for instance, vector databases, tensors, matrix data. Like NumPy array is good at it. JSON is not so good at it. DataFrames can use. DocArray can handle all of the types of data, which not all of the other data structures support. It's Pythonic. It's very Pythonic. It is aimed for neural search, so it has support for embedding and use with other deep learning frameworks. And then it's also a package it's a package that has rich functionalities for the most common data types: images, audio, text. You will find a lot of useful helper functions for visualizing images, for loading images, for processing them, for text, for chunking them, for hashing text, whatever, for building embedded index even, and so on. And for instance, another package that we have seen that is quite similar is this awkward array, that is also aiming for having an approach towards unstructured data. But the main difference is that awkward array is used as a columnar database, has a columnar approach, and DocArray is built for kind of a streaming datasets where it is more optimized for raw access. So in this comparison, we can see that, for instance, that iterating over a DocArray is much faster than iterating over an awkward array. But it depends on the use case that you want to build. And the main thing is that document and document array, we aim for this to be a good way to reason about neural search problems. Okay, so, and then this is the main data structure that Jina Core or Fine-Tuner or all the ecosystem or Jina Hub will use to build this awesome ecosystem for building neural search applications and scaling them. Okay, so it's important that DocArray is built and thought for optimizing the sense and the experience of using it locally. So it's the first entry point for someone that wants to use Jina, but is also having in mind that it needs to live in the cloud at some point. So it has efficient serialization and deserialization, and it's thought of. Okay, let's see some of the structures. So what is a document? What can we find in a document? For instance, we can have a unique identifier. This is important because when we index or when we can identify, it's important to be able to identify uniquely a document. Then we have all these buffer blob text. This is useful to contain any kind of data as a byte array, or any blob, any image or any audio or any video can be interpreted as a matrix. Text. Then we have a lot of metadata. We can fill the tags, so we can have our own schema there. Then document is also nested. What does it mean? A document contains itself a list of subdocuments, chunks and matches, because we identified that it's a common pattern for neural search to break up data and focus on different data, or to match data as a result of a query. Then we support embedding. It's ND-array. We support embeddings as NumPy arrays, as TensorFlow tensors, as stored tensors, sparse matrices, and everything. Then, since we are expected to be used by deep learning engineers, we always have to support the scores or evaluations. So this gives you a hint of what you can find in this package and how you can reason about all these type of solutions and application. Then we can see that we can serialize to JSON, from JSON to bytes, so that we can send to the cloud, or we can share with our colleagues. We can represent this as dictionary. We can use it as a protobuf object, so that if you want to use it with Jina or with other production systems, you can use them. Then you can apply embeddings of any type. You can use arrays, MP arrays, sparse matrices, stored tensors, etc. It's important to understand that document is a nested structure, so it contains matches and chunks. This is important for the completeness of applications. So a lot of times you might have an original, for instance, let's think about text. You might have a full book or a page, but actually the search, you want to do it at different depths, at chunk level. So you might want to do the search at sentence level, and then have matches at sentence level, and then bubble them up at root level. So all these combinations are thought for, and this is a data structure that will support all these patterns. Then you can have visualization for embeddings, you can have useful summarization of what is inside documents. And then a Fluent interface is as a good data processing library. All documents can be, all the functions can be applied with this Fluent interface. Then we have document array, that more or less is what you could expect from a list. It feels like a list of documents, but it has more under the hood. For instance, you can access attributes from the documents with this with some special quite Pythonic interface, and then it also allows you to traverse around chunks, matches, and also to do embedding directly from neural networks, and do even matching using neural networks. So I would recommend for everyone to take a look at the package, and we hope that you can get hooked to this package and love it as much as we do. And we hope to get it in much better shape in the near future.
Perfect. Thank you so much, Joanne. If you want to find out more, you can go to our DocArray repo or docArray.jina.ai to read up on everything, or just go pip install DocArray. Someone on YouTube mentioned they missed my ridiculous glasses, so you're welcome. Never let the fans down. All right, over to Nan. And remember, any questions, leave them below. Nan, are you there? Nan, I think is there an issue with your audio? Bear with us. I think Nan is having some technical difficulties. And we can't hear anything. Okay, Nan will be right back. So in the meantime, I'm seeing in the chat that people are digging the cool projects. Thanks, Marcus. Nan was saying if you want to find indexes or any kind of encoders, loads of stuff, you can go to hub.jina.ai. That lets you build a Jina app really quickly, really easily without having to integrate your own neural networks or models. We've done all the hard work for you. Looks like Nan is now back in the room. And fingers crossed. Ah, don't you just love Zoom? Do we have a backup? Anyone who can speak about RocketQA just in case Nan is completely unavailable?
Hey.
Hey, we hear you.
Am I back?
Yes.
Okay, great. Yeah, so I will stop sharing. Yeah, I will just stop my video because it seems like it takes quite a lot of resources.
Okay, cool.
Okay, let me start sharing. Okay, can everyone see my screen?
Loud and clear.
Okay. Okay. Yeah. Okay, welcome everyone. Just minimize this part. Okay. Yeah, welcome everyone. So, yeah, I think maybe some of you have already noticed that we have. Let me check. There's some notation. Okay. Anyway. Yeah, maybe some of you already noticed that recently we have published a blog post about our synergy with RocketQA. So RocketQA is a library for training open domain question answering system in end-to-end fashion. And yeah, and it was on the Microsoft Markov passage ranking leaderboard last year until July last year. So it has been there for the whole year. And recently the RocketQA team just released their code and models on GitHub. And we are proud to build a synergy together with the RocketQA team and have the RocketQA model published on Jina Hub as well. So, and last year, the RocketQA team also have 3 papers accepted by the tier 1 meeting conferences on the NLP side, like the EMNLP 2021, ACL 2021, and NACO 2021. So what is the open domain question answering system? Yeah, well, a very straightforward example is actually the doc bot we have in our docs.jina.ai. So here you can ask what is Jina, and then we will just go through our documentation website and find the right answer for you. So this is a typical open domain question answering system. We call it ODQA for short. If you want to really dig deep into that, I highly recommend you to check out the tutorial from Dante Chen and Scott E. Although it's a tutorial from ACL 2020, but most of the material there are still quite useful. And you can learn a lot of basic knowledge about ODQA from this tutorial. Yeah. And in general, modern ODQA system has two parts. So one part is so-called retrieval, and the other part is called reader. So as you can see here, we give an example. So when you give a question, what is Jina? And this question has been sent to the retriever. The retriever will use either the traditional term-based method like the BM25 or TF-IDF, or they can use a vector-based method to retrieve candidate context. So this context actually contain the potential answers. For example, here we will find two sentences. One contains the exact answer, say Jina is a neural search system, and the other doesn't contain exactly the answer, but all this context will be retrieved by the retrieval. And afterwards, this context will be sent to the second part of the system, which is called reader. Then the reader will extract the answer based on from the context based on the question. So here, as you see, the reader will find out the right definition of Jina is a new research framework. And nowadays, actually, the reader part is a relatively stable. I mean, like the model behind the radar part is almost all the same in different papers. So the researchers mainly focus on the retrieval part. And RocketQA is also focused on the retrieval part. So let's take a closer look at the retrieval part. A very intuitive idea to do the retrieval is to use the BERT model. So you can use the BERT model to encode your question and your answer. Then you get the vector representation for question and answer. You can compare them and find the right answer for your question. Well, this method works to some extent, but apparently, like here, the question is what is Jina, and the answer is Jina is a neural search framework. So these two sentences, the question and the answer, will actually have very different semantic meanings. When you're using the same BERT to encode them, well, the vector representation between them will be very different. So a very nature extension would be say, hey, we can use two BERT model to encode the questions and passages differently. Then you can train this two BERT model. Then you can train this two BERT model with the question and answer pairs to make sure the encoding from these two different BERT models are in the same vector space. And this is exactly how the RocketQA solved the problem. So in RocketQA, it used a dual encoder, so which including two BERT model. Besides that, it also includes another part called cross encoder. In the cross encoder part, the authors proposed to concatenate the question and answer with a with this SAP token, and then just have another BERT model to learn the cross attention over the question and passages. And they found this cross encoder actually improves the quality a lot. So basically, you can consider this cross encoder as a re-ranking part for the context. Okay, so here this is some result after running RocketQA on the documentation website. We have when you run the question, when you ask the question, what is Jina? As you can see, if you only use one BERT, the answers we found is well, actually not so related. And if you only use a dual encoder, the results are somehow good. You can the model can find the right answer, but the ranking is not ideal. Like the first the first answer actually doesn't answer the question, and after adding the cross encoder, the right answer is ranked at the top place. Similarly, I also checked another question, how to install Jina. We observed a very similar pattern. Besides this dual encoder and cross encoder pipeline, in the RocketQA, they also proposed a way to train these two models simultaneously in the end-to-end fashion. You can find more details information in our blog post. So here I leave the link of our blog post, and also you can find both dual encoder and the cross encoder in Jina Hub. We also provided a simple demo to show you how to build a ODQA system with Jina and RocketQA. And that's all about the sharing from my side today. And last but not least, many thanks to the RocketQA team. And you can find their the repo here. I also leave the link in the slides. Thanks for them for sharing the code and the model. That's all about the sharing today. Thank you. Any questions or comments?
Nan, you're still sharing your screen.
Yeah. Oh.
Hang on, I'll stop share. I can sort that out.
Okay.
There we go. All right.
Okay, thank you.
Awesome. Thank you, Nan. That was really interesting. And some super cool projects. We're all really excited about integrating RocketQA on the hub. And yeah, if anyone wants to try it out, it's just a few lines of code to integrate it into your Jina program. All right, so moving on, we've got some community members who are either returning or new. Christoph, Giancarlo, Deggy, it's good to see you all again. And Marcus, your name seems familiar. I'm not sure if you were here before. But if anyone wants to talk, we'd love for you to introduce yourself, talk about what you're building with Jina or hoping to build. And yeah, just get to know us a little bit. So yeah, if you want to talk, raise your hand or mention it in the chat, and I'll give you the ability to speak. Okay, a question from Giancarlo. What about training and fine-tuning? RocketQA is pre-trained on what corpus? Is it necessary and or expensive to fine-tune it to your own data? Nan?
Yeah. I actually asked the RocketQA team previously the same question. So so far they haven't released the training code yet. Yeah, so you can find some code snips in their repository for training, but it's not properly written. So the short answer is no, you can't fine-tune the model yet. Yeah, but let's see. The RocketQA team actually has a plan to release the training part this year. Actually, another like challenge for fine-tune the QA model is to prepare the training data, because you really need the question answering pair, which is relatively expensive to collect in practice.
Yeah, data wrangling. What joy. All right, any other questions? Okay, we've got something else in the chat. I'll check YouTube as well. All right. Thanks to all our YouTube viewers. We've got quite a few of you as well out there in YouTube land. Okay, so Priyansi or Suyan or Degi or Christoph, do you want to say hello? I will give you all the ability to talk, and then that choice is up to you. Oh, Giancarlo, you can say hello as well if you want. We'll just silence all the Jina people.
Yay. Hey guys, hello everybody. Nice to see you, and pretty interesting today as always. And I hope everybody is doing well. Happy New Year.
Thank you, and Happy New Year to you too, and everyone out there. Yeah, I'm sure 2022 will be wonderful. What could possibly go wrong? So, Yuan, do you want to speak through your mic as well, or just say hi in the chat? Either way, it's great to see you. Not in a good environment to talk. No worries. All right.
Maybe I can. Hi. So maybe I can take the opportunity to introduce myself as well. I've been following the meetings for quite a while now.
Hang on, I'll promote you to panelist. Do you want to do video?
Sorry?
Do you want to do video?
I don't have my webcam with me at the moment.
Okay.
But yeah, I'm an AI research engineer in Sweden. Have been following Jina AI for quite a while now, and been loving all the work, and been really motivated and fascinated by all the cool projects and how easy it is to build really cool stuff with it. So yeah, just wanted to say thank you very much, and love to see all the great work.
Oh, thanks for the kind words, Marcus. What are you building with Jina, or planning to build?
At the moment, it's mostly hobby projects, things I like to test out myself. So right now, I'm trying to build a indexer and smart search for multiple documents. So I want to be able to search, do semantic search across research documents. So the demo that was shown on the last meeting was really interesting, because I'm working on something similar, but I also want to include, so when you search for something, that you can highlight it visually and verify that the search results matches the pattern that you are expecting. So yeah.
Interesting. I think we had a lyrics search example with a front end some time ago that did just that.
Oh, really?
Highlight all the matches in a really nice GUI. That's in a deprecated repo, but yeah, the functionality is definitely there. If you go to our GitHub profile and find our examples repo, like I said, it's deprecated. The code won't run out of the box, but it's something. And yeah, if you join our Slack, our engineers will be happy to help out in any way they can.
Super cool. Thank you so much.
Hey, our pleasure. All right, chat's been going bananas. Okay. Nice. All right, anyone else want to speak? Deggy, I unlocked the mic for you as well if you want to say hello. All right, silence is golden. So yeah, if anyone wants to say hello afterwards, yeah, just join us on Slack, slack.jina.ai. Oh, and we've got a question over YouTube. Awesome, from ABD Shomad, Abd. I don't know how to say your name, I'm sorry. So to store the vector data, which platform is preferred?
So there is no, I might answer this one. There is no preferred. We support, and it will feel as seamless as any other for NumPy arrays or torch tensors, whatever is more handy for you.
In terms of database backends as well.
So right now we don't support any database backend, but it's something that we might look into.
Awesome.
But you can store locally right now.
Yeah, certainly when I build anything, it's all stored in a workspace folder. So yeah, cool. All right, anything else? Thanks, Christian, for posting the lyric search example. All right, in that case, we can wrap things up. Yeah, so last but not least, if you want to learn more about Jina, best place to do that is on our GitHub repo at get.jina.ai. Join the conversation on slack.jina.ai. We're very friendly, we don't bite hard. We're on the usual places as well, LinkedIn, Twitter, YouTube. We don't yet have a TikTok dance, though if one of our community members wants to come up with something, we'll be sure to send some swag your way, just for the sheer amount of effort. Yeah, good stuff. Thanks for joining, everyone. The next Engineering All Hands is a month from now, as always, second Tuesday of each month. So that means it's on the 8th of February. If you want to speak about a project you've built, or speak about your experience using Jina, or even your experience in AI and open source, drop us a line on Slack and we'll talk and we'll see what we can do. It'd be great to have you there. All right. So just nothing left for us to do except say goodbye. See you next time. And yeah, chat more in Slack. Bye-bye, everyone.
Bye-bye.
Hi, everyone.
Ciao.